Good morning and welcome to our webinar on modernizing your statistical computing environment. Today we have our Vice President of Health and Life Sciences, Tim Hughes, presenting. You should see a Q&A chat box on your window where you are welcome to submit questions throughout the presentation, and at the end we can unmute everyone and or answer the questions that have come in through that chat box. The other item I wanted to mention is that the session will be recorded and we'll be sharing the recording after with everyone on the call. Thank you for joining. Tim, over to you.
So hi, everybody. As Karina mentioned, I'm Tim Hughes. I run Domino's Healthcare and Life Sciences vertical. And today we're going to spend the next 45 minutes or so discussing this idea of modernizing your statistical compute environment, which is a broad trend that we consistently see across our life sciences customers. And that we're excited to discuss with you today. And specifically what that actually means when you boil down those challenges, what we've seen as robust solutions in that space, and then really how Domino maps and can impact those particular pieces of folks' initiatives. And so to lay out the goals and agenda for today, it'll be the following. First and foremost, we'll discuss the challenges in and around modernizing a statistical compute environment with specific regard to digital transformations. So that's pretty often how we actually see this come up. Hey, we have a broad digital transformation happening inside of our business. Very much so that oftentimes means we're migrating to the cloud. And so as we migrate to the cloud, let's go ahead and look at how we operate our on-premise statistical compute environments and address the historical frictions and challenges that have existed inside of that particular workflow. We'll then share best practices we've seen for solving these challenges, both ourselves as a software vendor, but also that we've seen our customers implement. We'll walk through a particular case study of one firm's set of challenges as they documented them, the solution we put in place, and then the impact we saw. And then finally, time permitting, we'll do a brief overview demonstration of Domino, highlighting a couple of core aspects of our platform, and particularly how that can map directly into addressing those challenges and introducing a really nice, robust solution for your research and data science teams. So to continue with this idea of level setting, what does it actually mean to modernize your statistical compute environment, and what does it mean to have this digital transformation? Obviously, it means lots of different things to lots of different people, and for us, this is how we think about it. First and foremost, we want to go ahead and lift and shift our current statistical compute environment to the cloud. Today, that SCE is oftentimes lots of different deployments of lots of different technologies, all of which have the same requirements in terms of what they have to do in order to satisfy internal, external third parties. And so as you migrate to the cloud, how can you optimize that and how can you continue to satisfy those requirements? Looking at the kind of modern technology stack and the rapid pace of innovation that we're seeing inside of the diverse set of tool sets that folks need to use to actually do their job, and the set of tools that people want to use to actually do their job is rapidly changing. And so how can you actually use this change in this new technology stack to help support those diverse set of tools in a way that is really robust and has a vision and a thought for really long-term success? The next piece we would want to point out is actually we think about the technology choices you make in terms of baking the kind of those best practices directly into the systems and softwares you're using. So best practices for research and analytics shouldn't be just people workflows and processes and things that humans have to think about as they go through their process, but really how can we go from a world where every time I execute a part of my research process, the tools and systems that I'm inside of can systematically track and understand what I'm doing and use that information to help alleviate downstream concerns or workflows or requirements that I historically have had to address with human intervention. And then finally, if you can enforce and automate a lot of best practices in your research workflows, then when it comes time to actually engage with downstream third parties that are either internal or external to your firm, you can really expedite the process by which you are going to do things like document your work or submit your work to a regulated body such as the FDA. And so today, we're going to talk about, not only the best practices and challenges in and around that, but how Domino maps directly into that world and how we can help alleviate and accelerate that process. So let's double click into those core challenges that we typically see. I'm going to lay out the 6 common themes that we consistently see across our entire client base and certainly all of the customers that we engage with on a daily basis. First and foremost is this idea of unreliable and inadequate access to computational resources. Data is getting bigger. The analyses that people want to do are more intricate and require a really robust and diverse set of computational resources. And traditionally in the on-premise operating model, what we find is that getting access to these machines can be really cumbersome, hard, and significantly slow down and impact the pace at which people can execute in their research processes. The next piece is that the cloud oftentimes offers a really good solution to the problem in point number one, but moving to the cloud is non-trivial. There's lots of challenges that actually go into executing a cloud strategy quite well, and you really have to think about the workflow and the way in which your researchers access those cloud computing resources, and also the support folks, the technology folks who are actually going to be responsible for delivering those cloud compute resources to your researchers. How are we actually supporting them in doing so? And oftentimes what we find is that migration to the cloud actually introduces more problems and more challenges and more friction into the workload. So really thinking smart and hard about how can we actually alleviate those problems that oftentimes come up as you move to the cloud. And then naturally, you have, again, that diverse set of languages and tools that are going to be moving from that on-premise ecosystem that have those requirements in and around an SCE. You're moving into the cloud. And when you move into the cloud, you can't risk the ideas that are really kind of key to everything we're talking about today around quality and validation and audit controls and governance. And so as you migrate to the cloud, as you introduce new technologies and capabilities, and as you introduce new tools, really being smart and thinking about, okay, well, how do I make sure I don't break all of those mandates and all those requirements we have? And we've seen that that's been, a big challenge and a big thing that actually people have to lend a lot of mind share to do well. And really then, this idea of systematic collaboration, I think, is really interesting. Oftentimes what we find is that collaboration is thought about at the kind of individual researcher level. I'm collaborating with myself. I'm engaging with my past work. I'm collaborating with my colleagues and my peers on a particular analysis. What we really think about it is that collaboration it's an institutional capability. It is something that happens across all sorts of diverse sets of folks inside of your organization. And certainly when it comes to this idea of an SCE, you're working with internal QA teams and audit teams and teams that are helping you get your work ready for kind of the next step in your process and pipeline, and finally for submission. And so if you don't have a way to systematically handle and understand the work, the evolution of your work, to have a single repository of all that work, there's lots of friction that gets introduced to that collaborative workflow. And so that's something we commonly will run into is, hey, how can we make our collaboration efforts really robust and strong across all of the stakeholders that are engaged in our work, especially in light of this overarching theme again today of the statistical compute environments that we're operating inside of. And then obviously, if you have all these requirements you have to meet, if your systems and your technologies aren't going to support them automatically or alleviate a lot of the pain that typically goes into operating in this environment, then what you do is you have a lot of post hoc efforts that are typically human intervention to come in and manually go through a process of auditing your work, documenting your work, going through the process of understanding the specific versions that eventually led to a particular analysis and outcome. And it just takes a lot of time and effort. And that time and effort is anytime it's spent on these kind of manual processes, it's less time you can actually spend on furthering your analysis or moving on to your next project. So how can we reduce really the time burden that a manual process puts on everybody? And last but not least, we always hear this, and I think this kind of harks back to point number 4 as well. Quote unquote management, the folks who are helping optimize how resources are being deployed inside of your organization, today have a very hard time actually having full transparency and understanding the state of the work across their group or their entire organization broadly. And that lack of transparency can cause significant losses around the velocity in which you can deliver outcomes, but also the quality in which you can deliver outcomes. And so really just these are the common things that we run into. It's kind of amazing to see how consistent they are across all firms, and how much they oftentimes map to this idea of a digital transformation and this modernization effort of folks' statistical compute environments. So naturally with challenges, there's oftentimes solutions that folks are pursuing, and it's been really exciting to actually see the approaches and the solutions that have been put into place for some of the best and most successful organizations we've engaged with. And as there are 6 challenges, we're also typically see these 6 best practices at scale. And so to step through them, the first is that this idea around we really want to go ahead and treat research as an organizational capability. So as we make all of our technology and design decisions, we always want to think about it from this overarching goal is that it should be feeding into a centralized repository that can actually allow us to scale this process. So we want to eliminate as much as possible this idea that people go off and design a one-off solution, or we have this kind of wild, wild west of folks repeatedly going through a process of seeing a problem, designing a point solution, implementing the point solution. And every time that happens, that creates sprawl, that creates silos of knowledge, that creates non-standard processes, and that really prevents people from wanting to do what they want to do, which is have a single place that actually is built from the ground up to handle all workflows, all types of workers, and enforce those best practices. So again, just design for scale and think about anytime there's a point solution that's going to happen in an isolated silo, we want to avoid that and think about how can we actually again, drive all of these processes to happen in a single place. The next piece would be is the technology choices that you make. They can either be solely built around solving a point solution, or they can be built around solving a point solution while at the same time enforcing best practices and starting to automate the things that you know you're going to have to do at some point in your work. So reproducible research is obviously a best practice, but how can you make something like reproducible research and audit trails and all of the things that have to go into that idea of a modern statistical compute environment? How can you actually bake it into how you work? And so look for technologies that automate and reinforce and make things like an audit trail and things like manual documentation. You can alleviate that. You can really start bringing all of these best practices directly into just how you operate and make things coincide with each other. So if I execute a process, that process is just going to automatically be tracked, versioned, and understood in a centralized place where lots of people can see and access that information. The next piece would be is thinking about this ecosystem or this place that I'm doing my statistical compute work. It needs to be an open environment. It can't be tied to a single type of technology. It needs to be flexible both in terms of tools, infrastructure, and data. So if I want to use SAS, MATLAB, R, Python, or a long list of kind of esoteric domain-specific technologies, the place that I'm doing my work, this modern statistical compute environment, has to support all of them. And it has to do so in a way that obviously satisfies enterprise standards. So how can we actually approach building a foundational place that we go to do our work that supports all the tools and technologies we want to use, while at the same time making sure that as I use those tools and technologies, it's really calling back to point number 2 here, where it methodically automates and tracks and understands what's happening, where, when, and how in a way that actually allows us to have confidence that the use of these tools and technologies in an open ecosystem are done so in a way that is not going to violate any of our stakeholders. The next piece we see that's really consistent and exciting is this idea of, as much as possible, standardizing the research process from like a templatized approach. Where can you actually go ahead and start enforcing best practice and giving people reusable artifacts that then feed into this idea of a reproducible, validated, and controlled workspace? And what we've seen for this is that obviously it can help with the kind of the people and process perspective of reinforcing and presenting people with a common way to go about their work, which then obviously feeds into higher quality outcomes and processes as it relates to those ideas around reproducibility and validation. But it also really helps with this idea of onboarding and ingesting new researchers into your organization. You know, one common thing we typically see for folks is that as they come new to an organization, there is friction around understanding how the technologies work, how the organization works, and then finally how information is documented, processed, and kept for the long term. And the more that you can actually get these processes standardized and repeatable and really accessible to folks through a templatized approach, you can get really, really fast onboarding experiences where people go from their first day at the organization to their first time making kind of a real impactful insight in a much more compressed time frame. And then naturally, especially in today's world, we're seeing this to be a huge challenge that folks are approaching is the place that you're working, your statistical compute environments, they have to be accessible really from anywhere, any place on Earth, and it has to be built with this idea that folks are going to be distributed. You know, gone are the days of being able to really just turn around and ask a colleague a question or walk down the hall and pop in somebody's office. We need to be able to build a system from the ground up that's going to facilitate remote work. And so in some sense, you know, the idea is that exists in a statistical computer environment around audit trails and reproducibility and understanding of what's happening are what actually supports really great remote workflows. So a distributed team that has folks that are based on the East Coast of the United States and India who are operating on completely different time frames need to have a way to access really something that's like a web browser that allows them to see kind of, hey, here's all my work that's been worked on by myself and my colleagues. I can access it, I can interact with it. And as I want to take that analysis down to the next step, it doesn't require me to have access to, a large server that sits under somebody's desk somewhere. It's going to really go ahead and facilitate all of the distributed workflows that I would need from a collaboration perspective, but also at the same time give me direct access to powerful cloud infrastructure in a way that's going to also reinforce best practices for myself. And then as I pick up my colleagues' work and I execute the next step in my processes, as I go home for the day, it's very easy for my colleague to step back in and see, hey, what have I done? What haven't I done? And really what would make sense for them to do next. And then finally, the last piece we would probably point out is that visibility, communication, and measurement are huge. And so again, I think this is thematically touched on throughout all the things that we see in the best practices above. But as you take a step or an exercise in your process, as you execute something, as you spin up a notebook, as you run a batch job, or as you explore some type of data set, by being able to provide visibility and understanding to what you did, where, when, and how, you are going to facilitate a process that encourages this idea of communication and measurement and visibility in a way that allows you to satisfy all sorts of concerns you may have, from reproducible research to making sure that your work is documented in a way that downstream stakeholders can consume in a robust way, all the way through to how you communicate with your peers and make sure that your peers are on the same page as you guys collaborate and move through your research processes. Basically, what I've laid out today is, we see a common theme, this broad transition to the cloud. This broad transition to the cloud is, gets called this digital transformation. Bucketed within that is this idea of a statistical computer environment modernization effort. And that SSC kind of modernization effort comes with a number of challenges or things that firms consistently have to think about and grapple with. And then we see this common set of kind of best practices and solutions put together in order to address that. And what's interesting is how we think about actually how do you take those challenges, those best practices, and you boil it down into some type of foundational technology. And this is where I'll do a small shameless plug of Domino. This is our approach to this. We do not want to introduce some type of new point solution. What we want to think about is that research teams and anybody in and around the research ecosystem who is going to be supporting those researchers or consuming their outputs need a single place, a platform that they can go to actually just do that work. A place that really just thinks about managing and curating the knowledge that is being generated in and around these activities. And so for us, what we see is that regardless if you implement Domino or some other solution to those set of kind of challenges and really good best practices, is you need to have a platform established. You need to have a tool, infrastructure, and data agnostic place that people go to do this work. And then that platform needs to be really focused on two broad areas. It needs to be focused on how do I give my researchers a faster, more repeatable research process that reinforces best practices and addresses all those key challenges that we've laid out so far today, while at the same time, as they execute that research process inside of this platform, and as that platform automates and enforces those best practices, allow that information that flows through that system to be captured and repurposed in a way that actually allows you to accelerate and drive all of the organizational next steps that follow the results of an analysis. And so for us, what we commonly think about, or this idea or mental model we try to introduce, is treat your research teams as an organizational capability the same way you treat any other function inside of your business, where you wouldn't run a sales team without a CRM or an HR organization without something like Workday. We really think about you should not be running your research organization without something like a data science platform or without a Domino. And so as opposed to taking an approach where I see a problem, I introduce a point solution that's built around technology, let's take a broad step back. And let's actually think about how can we establish a single place, a platform that's going to support all the technologies that we need to use and the tools that we need to use, and built in a way that's actually going to allow us to adopt all sorts of new tools and technologies over time. But let's make sure that really the pure goal of that platform is to consolidate all of your research efforts into a single place, and then have that platform be really, really smart about thinking, how am I going to actually automate, augment, and maximize the value of the work that flows through me? And so that's really our approach here. And this is how we think about and see kind of the top organizations that we engage with solving this problem, this effort. And so with that, I actually want to go ahead and transition and start talking about, a specific use case and case study of a large global pharmaceutical company that we partnered with to actually go through, essentially what is everything that I've discussed today. And so in order to do that, I'm going to walk through some of the challenge, the solution, and finally the impact that we saw in terms of what this firm was able to do in partnership with us. And so the first thing I would lay out is that often the challenges are following. I think these challenges are really important to highlight because they are, again, very consistent from firm to firm. The first thing I would point out is that the size. When we engage with most of our customers and any of the kind of the net new firms that we're engaging with for the first time, one thing that seems like a daunting task is the number of folks that they have to take care of. So we have 500 plus researchers and data scientists in an on-premise ecosystem using typically tens of different systems to actually drive their research process. How am I going to lift and shift all of those folks from an on-premise ecosystem to the cloud? So size and scale is oftentimes a daunting task. And then when you think about the further problem there is that because they've been operating that model for so long, you have these really, really rich, siloed, isolated buckets of information, and they don't want to lose all that historical information. And so they want to think about really robustly, hey, how can I take all of those silos, move them to the cloud, collapse those silos into a single platform while also not losing all of that work that existed before? The next piece is obviously a digital transformation part of it. We're moving to the cloud. As we move to the cloud, we got to adopt the cloud and make it a core capability and really leverage the cloud for what it is in terms of cheaper storage, easy access to compute, a diverse set of types of hardware and machines, this ability to have elastic compute, so burst up and down as needed to save costs when you're not running things. So to really think about that and what does that mean for a biopharma research organization, and also to obviously drive innovation and unlock new capabilities. As you obviously move into this new world, reproducibility, collaboration, discoverability is huge for how we always operate, but certainly the regulated environment is increasing in terms of intensity. And the more intensity that comes in and around that need for reproducibility, the more time we tend to spend with humans kind of going through that manual process. So let's go ahead and start thinking about, again, how can our technology decisions actually reinforce these best practices and just bake it into how we work, and therefore reduce the burden and accelerate the pace at which we are actually executing our processes. And then finally, what we haven't really talked about at all today, or really just briefly touched on, is there's this idea of once something's actually built, we need actually a way to expose it to the next step in the process. So, who is actually going to consume our outputs, and when they go to consume it, what is the form in which they're going to consume it, and what are the ways in which we can help facilitate that? And so in this particular case, they had 400 different quote unquote consumers. Consumers means all sorts of different things, from downstream systems that want to ingest in an automated way the outputs of a particular research pipeline, all the way through to, actually to take a little bit of a right-hand turn here, all the way through to things like sales and marketing. So we have sales and marketing teams that also are going to be leveraging these analytical environments. And so our consumers come in these wide range, shapes, and forms, all from humans all the way through to automated machines. So with that challenge, the solution that we implemented, obviously part of it was Domino. I will say that to do this at scale and to do this well, there's lots of things that actually come together in and around Domino to create a fully reproducible system of record for data science. But Domino really serves as this idea of a backbone for it. It's the place that people go and use for their core workbench, and it's driving and solving a lot of the core challenges that we've laid out today. The first thing I would point out is that the complexity and sprawl of that on-premise ecosystem of 500 plus researchers across lots and lots of silos and pockets of technology immediately can be collapsed into a single platform. So we're taking users of R and Python and MATLAB and SAS and a whole host of more esoteric, domain-specific tools and consolidating them into a single platform. That single platform is going to be cloud native in the sense that it can spin up and automate your cloud resources and technologies you need to use, while at the same time, it's going to be tool agnostic. So it's going to go ahead and support really anything that can be run on a Linux machine, allowing people to have a single point of entry to access any of the tools that they want to use. But it also gives all of your technology partners a single system to actually have to automate, maintain, and think about improving over time. So if I need to introduce a new capability to my quote unquote data science or research platform, I make one change to one system and everybody inherits that update, that change, and that innovation, as opposed to historically what we've seen is hey, I have 15 of those technology stacks that exist. And so if I want to introduce a change or an improvement that needs to happen across all of tools, I have to implement that 15 times, support that for 15 different stacks, and then maintain it throughout time. Also, because you can also create this idea of a single platform or single entry point, it also makes this idea of a shared catalog of data sources and tools and what's available to research teams much more streamlined, easy, and accessible. It cuts down tribal knowledge and can make sure that things that are happening in and across the organization are all understood and known in one place. That chips away at a lot of the themes that we're talking about today, especially from that audit and regulatory perspective, really ensuring that folks aren't engaging or leveraging things that they shouldn't be. And when they are engaging and leveraging things that they should be, people know and understand what's happening, where, when, and how. And then finally, the biggest thing that I think we commonly see is, again, this idea of knowledge and results sharing and information being accessible in a single place really does drive kind of the value of what we're trying to accomplish here, where knowledge sharing really just isn't about, hey, we have some IP and I want to share it with my colleagues who are purely in research. It's we have IP that drives all sorts of different parts of our businesses and processes. And so all sorts of different stakeholders want to engage in my information and my work for different reasons. So how do I make that easy? And when we talk about easy, it means a single place to access that. It really has robust audit trails. It's really clear for me to understand who did what, where, when, and how. And because I can do that, I have this sort of self-service access point to all of our information that then drives fantastic outcomes. To dig a little bit deeper into there, and just to kind of briefly touch on this, and I'll do a quick time check. The implementation effort was to start, 15 teams spread across this on-premise ecosystem. We had to think about how do we do this systematically? So there's going to be phases and prioritization efforts. We're going to think about readiness to adopt for different teams, understand the applications they're using, and are those applications ready to be moved to a cloud ecosystem? And if they're not, what does it mean to actually get them ready to do so? So there's this kind of internal survey effort to understand who needs to move, what needs to move, and when can they move. We then match them up with our internal experts who are really going to be subject matter experts and have a lot of experience engaging in that process that I just laid out beforehand, which is thinking about how do I lift and shift all of these technologies? How do I lift and shift all of this historical information? And then as I do that, how do I make sure the migration of how people work goes smoothly? Naturally, because again, this idea of implementing a tool agnostic platform that facilitates and chips away at all these challenges means that folks don't have to learn new technologies when it comes to where they actually do their work. So they're still using R, they're still using Python, still using SAS and MATLAB. None of that changes. It's really just where they access those tools and technologies changes. So the transition can be done in a pretty frictionless way, but there still is a learning curve and there's still a process of going from to. And so partnering with them to make sure that happens and that goes well. And then naturally, I think that's all part of point two is this internal training and competency and onboarding process. The last point I would call out there is we really think about this again and more broadly than just your research teams. In order to do this really well, the training and competency really should exist from your technology teams, your research teams, your management teams, and then all of the people in and around those teams that are relying on their work should have a good understanding of how to operate in this ecosystem and how this ecosystem being established actually can impact their day-to-day in a positive way. So what was the outcome? I think net it was just is really exciting to see what we were able to do. And to not talk through the slide, it is more productive and faster research processes. Every time that those research processes are being executed, it's enforcing best practices, it's enforcing reproducibility, it's creating a single place that's agnostic from tool and infrastructure and technique that owns and understands who's doing what, where, when, and how. And then all of that activity and information flowing directly into a single system allows allows them to take all that information and curate it, optimize it, and manage it in a way that impacts, again, all of those stakeholders that exist in and around their research efforts. And so it's been really exciting to see the outcomes we've been able to drive. And it's been really exciting to see the impacts we can have there. So I know we are about 32 minutes in. And so the last thing I wanted to do here for 3 or 4 minutes is actually just hop into the product and give folks a taste of, how do we actually bring these ideas that we've been discussing to life? And then I'll pause for a few minutes and talk through a few questions before we end for today. In order to do that, because I'm going to kind of drop into Domino just in the middle of the product and start going through things, and won't be going through that kind of proper setup and giving you a mental map for how Domino works. I want to just briefly use this slide to form some type of mental model for what a Domino is and how it operates. So you can think about Domino as just a piece of software represented in the blue here that deploys directly into some type of infrastructure that you own. It could be on-premise, it could be AWS, it could be Azure, it could be GCP, and Domino gets deployed directly into that ecosystem. And then the first thing we do is, as a part of these modernization efforts, is we're taking the big sprawl and lots of different isolated systems of R, Python, SAS, and MATLAB that live in these silos typically on-premise today. We're breaking them all down, we're containerizing them, and then we're executing them centrally through Domino. And then once you do that, Domino is going to facilitate a number of functional workflows in order to facilitate supporting those tools, technologies, and research processes. And those functional processes are what's represented in the blue here in the white writing. First is compute grid. You can think about that as self-service access to machines and infrastructure. I no longer am going to be required as a researcher to have a request and response model from, if I need X, I request it, and then my technology partners respond by providing me that. It is now a workflow where I am given access to a certain set of computational resources by my organization, and I have a workflow that allows me to kind of fully automate the experience of getting access to to that infrastructure in an on-demand fashion. The next piece is an approach to environment management that's unique. So an environment in Domino just means, what software and technologies am I using at runtime? And we treat these environments in a unique way. We treat them like most people treat source code. So environments on Domino are tracked, revisioned, shareable, permissionable. And you can see a complete audit trail of everything that's ever happened to that environment. So if you have an R environment or a SAS environment or a MATLAB or Python environment, you can actually see the complete history of changes and who made those changes and why those changes were made, the same way you could see a complete history and revision history of your source code. And then anytime you execute a process inside of Domino, we're going to go ahead and automatically enforce best practices around version control, where version control inside of Domino isn't version control just at the source code level, but really what I think about is at the experiment level. So if I execute something in Domino like a Python script, Domino is going to go ahead and automatically track and version everything that happened around that execution. So my code, my data, the results that are generated, plus all sorts of metadata like the machine that I ran my analysis on, the underlying computer environment I used, who ran it and when they ran it. All those artifacts are going to be tracked, revisioned, and linked together to create an immutable artifact that can be referenced at any time in the future and allow me to go back and completely reproduce some type of analysis or understand the process by which an analysis was arrived at. Finally, because all this information is obviously flowing through a single system, it creates a really nice sharing discussion workflow. That sharing discussion workflow drives broad level knowledge management best practices, searching, finding, discovering past work that's happened inside of my organization as a whole, or sharing discussion really at more of a project or a research level. I run an analysis. I want to talk to somebody else inside of my organization about it. I can very easily ask them questions directly in the context of my work and get their expertise and commentary around it. And then finally, something we won't touch on all today, but this idea of you build something, you need to deploy it. Deployment means lots of different things. How can we help accelerate that process? That is ending all of the talking for now in terms of just pure slides. And now I'm actually going to move off over into the actual product itself and highlight 2 or 3 core pieces of functionality in the next 4 minutes. And then I'll pause for about 5 minutes of Q&A. So I'm in a Domino project now. And the first thing in a Domino project is kind of a Domino-specific idea that I won't go through today. But when you're in a Domino project, as a researcher or as a user, you can come in and make really 2 specific decisions once you start your analysis. The first being, hey, I have this idea of I need to have self-service access to infrastructure in an on-demand fashion with lots of controls and governance around it. So in this case, my organization has actually given me access to a wide variety of machines. These are all AWS instance types. And my interaction point with these is literally just point and click. So if I need to do something on a specialized machine like a GPU box or a machine with lots of RAM or lots of cores, based off the type of worker I am inside that organization, I can come in, see what my organization is giving me access to. And then if I want to go ahead and use a, let's say this small 4-core 16 gig machine, I point, I click, I have access to it. From here on out, Domino handles all the plumbing infrastructure associated with actually getting my work to run on this machine. And as I use this machine, Domino will systematically track and version and understand how I was using the machine and why I was using this machine. Naturally, inside of this project, as you're going to want to probably choose lots of different types of machines, depending on what you're doing. Maybe a smaller machine for some work in a notebook and a larger machine for big batch processing. It isn't set at once and you're stuck. It's nimble and you can move through lots of different options. So I'm just going to choose a 1-core 1 gig machine for now. And then the next piece or next thing a person can really engage with is this idea of a compute environment. And a compute environment in Domino, again, is the software and tools that you're going to use at runtime. And so from a single dropdown, I can see all of the kind of the particular tools I want to be able to use in this analysis by coming in, seeing a drop-down menu of everything from SAS to MATLAB to Python to R. And my process for moving between these is, again, just a single click. If I want to be able to, potentially do something in SAS, maybe it's some extraction and transformation work. I come in, I choose that tool, I do my work, and then I can change it. Maybe what I want to change is to something in R and Python, and maybe I'm going to do some, visualization of that data that I extracted and transformed. And then finally, maybe the last piece I want to do is I want to flip to MATLAB to do some simulation tasks. And so again, the same way I'm just nimbly switching between different types of hardware, it's the same thing I'm doing with my software. And again, it's all from a single place, all from, in this case, even a single project that allows me to nimbly move through lots of different tools and have a really good understanding of what I'm using, where, when, and how. And so the setup here of establishing these two particular kind of settings choices, so machines and the software I'm using, then feeds into the first workflow that I want to highlight, and really probably the last workflow I'll highlight today in order to save some time for questions, is this idea that I can then start interacting with, hey, something like a web-based IDE. And so I might come in and say, I want to go ahead and do that, that ETL work that I was discussing earlier. So demo for webinar in SAS. So I'll choose my SAS environment. I have my hardware tier here that I've already selected, and I can go and say, hey, Domino, go ahead and spin up a SAS Studio session for me. And now mechanically, this is just a kind of like pure technology and DevOps workflows of Domino spinning up and providing me access to the tool that in particular that I needed. But what's really nice here, and kind of calling back to the core themes today, is this activity is being systematically tracked. So I can come in and see a dashboard of all of my past activities when it comes to my web-based IDEs and who's doing what, where, when, and how. And if I click into it, I can actually get some really granular information. So, this is the logs that are there, but ideally, you're mostly going to be looking at something like the details tab here. And this details tab is capturing exactly what happened when I perform this analysis. And in this case, it's showing me the command that I ran here, which is like, I'm spinning up a SAS Studio session, but then it'll also show me a snapshot of the state of the files at the start of this this notebook execution. When I finish, it'll show me a snapshot of the state of the files and the output files. It's showing me the type of machinery I used. It's showing me, literally the IP address of the box that I used. And then finally, it's actually showing me the very specific version of the compute environment that I use. So in this case, it's base SAS 9.4, and it's a particular revision of that environment. So revision number 24. As everyone knows, you're constantly maintaining, evolving, and changing these environments, whether it's SAS, R, Python, or MATLAB. And as that happens, you need to have a robust understanding and audit trail of why those changes happen and who made those changes and why they exist. And then certainly as you, basically run analyses over time, the environment that you used 6 months ago can be dramatically different from the environment that you're using today. And so having an understanding of what particular revision was used against your historical analysis really allows you to achieve that level of reproducibility that you want. And so, while I was talking through that, our SAS Studio session launched, and now I can hop over and I could start, doing some data prep activity if I wanted, or what have you. And then certainly if I needed to in this particular environment, I could go ahead and change change things up and switch to a different tool. So maybe I'll flip to MATLAB. So at the same time while I'm running my SAS Studio session, I can go ahead and spin up my MATLAB session, or maybe one of my colleagues working this project could do it as well. And I'm going to go ahead and kick off this MATLAB session. And this is just going to go through the same process that we've talked through already in context of the SAS Studio session. And we're also going to have the exact same tracking and audit trails baked into that effort and that process. So really, just by working inside of Domino, I'm forcing best practices. I'm creating a really nice workflow for accessing tools and infrastructure on demand, and addressing a lot of the challenges we've laid out today. So with that, I'm gonna pause and stop for now in terms of a poor presentation, and go ahead and take a look and see if there's any Q&A. Certainly, if folks have any questions, we'd encourage you to ask, submit those questions, and we'll go from there. But much appreciated, and really, we thank you for joining us.
And one question came in that says, does Domino impose any coding conventions to enable tracking of dependencies, or does it happen in the background?
Yeah, so it's probably it's worth whoever submitted that question, appreciate it. It's worth a more nuanced discussion to understand exactly what you're asking. But absolutely, Domino will handle tracking of those dependencies and helping you handle things like, for instance, R just upgraded to R version 4.0. When that happens and people upgrade to it, it breaks a lot of historical analyses. Domino has some really fantastic workflows for handling that and helping people go through that transition in a smooth way, in a smooth fashion. Obviously, I don't have the full details of what you might be interested in understanding in this particular context, but it would be a very common workflow, for instance, for us to go ahead and say, as you upgrade to R version 4.0, you want to also have a legacy R 3.5 version available for you. And in a project, you want to run your batch R script. So it's like training.R that runs against version 3.5. It produces a consistent result and expectation that you know and you trust. As you upgrade to version 4.0, you'd want to be able to run version 4.0 alongside version R 3.5 and then diff the two outputs, or understand when you make that upgrade, hey, what are all the underlying dependencies that break, and how do we want to approach that? So it's definitely something we can handle really well. And yeah, we'd love to engage with you and understand what's the particular scenario you're thinking of here.
How does Domino handle data access?
Yeah, good question. So we really are agnostic in terms of accessing your data. We do provide a wide range of ways for people to access data. That can be programmatically. So for us, we're not defining a particular workflow or protocol for which you have to access data, or requiring you to put data inside of Domino to interact with data. If you programmatically make calls in R, Python, SAS, or MATLAB to a Redshift database, an S3 database, an EFS store, those are all things that are supported really well inside of Domino. And our goal is to be, again, kind of agnostic and flexible in terms of accessing that data. While at the same time, we do offer native capabilities around managing data. So we have an idea in Domino called data sets, which is really allowing you to pull a data set into Domino and introduce a lot of really nice workflows around reproducibility, governance, and controls when it comes to a core, maybe training data set that lots and lots of people rely on. The too long don't read here is flexible access points, no real hard and fast rules, and the ability to really integrate with any data store that you're interested in, while at the same time introducing some native capabilities that are mainly addressing or particularly thinking about when you go through a large experimentation process, or you have a core data set that lots of people rely on, how can you introduce some new features to that data set that historically have been difficult to access?
Another question. Maybe this is probably one of our last ones that we can handle, but can you talk about how Domino supports SAS and MATLAB in the cloud?
Yeah, sure. So, the easiest way to think about Domino is that Domino is an orchestration layer sending containers to Linux machines somewhere in your infrastructure. That can be on-premise or it can be in the cloud. And so in the case of something like MATLAB or SAS, they both offer a containerized version of their product. And so that container essentially, quote unquote, plugs into Domino. And then Domino acts as an orchestration layer, basically in the case of, say, an AWS deployment, spinning up an EC2 machine, getting that EC2 machine ready to receive that container, and then deploying that container to that particular instance. And then you're just leveraging SAS or MATLAB like you would any other technology, whether it's R or Python. It's just, both of those firms are offering containerized versions of their software, and both are introducing web-based notebooks as well to help support and optimize a system, for instance, like Domino, where people want to interact with a web-based version of the SaaS IDE or the MATLAB IDE. And so, here I can actually just flash quickly. Here's an example of a MATLAB IDE running in a web browser where Domino is orchestrating and allowing that to happen. And then obviously we showed this earlier, showing the SaaS Studio web-based environment as well. And just, it works like you'd expect it to work. It's an IDE and you're accessing it through the web. And now I'm going to go ahead and run my analysis top to bottom and consume the output. And again, more than happy to dive into this. Obviously, there's lots of questions that typically come along with this. Like, SaaS and MATLAB have lots of different products. What products are supported? What aren't? What's the roadmap look like? And we're more than happy to engage with you in that conversation and pull our partners in that case.
Great, thanks, Tim. I think we are just about at our time limit for today. I want to be respectful of everyone's time, but there are a handful of other questions that came in. So we will follow up with folks afterwards via email or to set up a call to discuss answers to those questions. Thanks, Tim.
Cool. All right. Thanks, everybody. Thanks, Karina. Really appreciate it. And yeah, again, to reiterate that, appreciate everybody showing up today. And, please feel free to reach out and follow up with any particular questions you have. We'd love to talk about it.